Hello, everyone. Welcome to today's Deminar. Going to be showing you DSAIL 2.0. Very happy to announce that it is now available for everyone, and it's even on AWS Marketplace, and I can post a link for that later. All right, I'm going to run through the typical spiel, going to try to keep it to 5 minutes and explain where Jaxon fits into the stack, how can companies use Jaxon. So we are all about verifying that LLMs aren't fabricating information, so-called hallucinating, coming up with things. The issue here is that LLMs were trained on the world's data, and they are token predictors. They are going to look at all the patterns in that training and come up with the most probable, and that's the operative word here, probable answer to a prompt or to a question that's being asked. And for high assurance workflows where it just has to be right, that probability is just not possible. It is too risky to include an LLM without guardrails. A lot of the guardrails that have come to market are probabilistic guardrails still. So it's probabilities on top of probabilities, an LLM evaluating another LLM. Even with the new announcement from NVIDIA where they have diffusion models, it's still very much a probabilistic game. And so rules engines, good old-fashioned math, can prove that something is or isn't right. Yet rules engines of yore, and this dates back to even the 80s, are hard to create, hard to maintain, implement, make changes to, etc. So where Jaxon comes in is bridging the old with the new. So rules engines now can be powered by LLMs. We can use LLMs to create all the rules. We can use LLMs to enforce those rules. And we can get it into these solvers with our innovation here. We've been doing a lot of work with the Department of War and creating this technology for their use cases where it just has to be right. What DSAIL does is it converts natural language into code that gets compiled at runtime and formally solved. Solving, I liken it to a whole bunch of math, but think back to geometry where you're given a problem and you had to show a formal proof to the answer, and every step of your answer had to be right. Similar to how solvers operate, it can show you the whole audit trail of how a determination was made and whether or not a rule that's being imposed was satisfied, was not satisfied, or importantly, and this is how we really address the hallucination problem, is not enough information to make a determination. Whereas you ask an LLM, it's going to give you an answer no matter what. With our approach, it's going to flag that it doesn't have enough information to give an answer. So our innovation here really gets the best of both worlds. We can lean on the LLMs for what they do really well, which is interpretation, information extraction, determining that a question being asked of it is related to the training that it's already had. So it's pattern matching skills. But the reasoning is where we take over. So instead of having the LLMs reason, we are having them do the information extraction. I always like to hold up my arm when I'm describing this. Think of the programs that we are running through. I don't know why I did air quotes there. They're actually programs. Programs that we're running through these solvers have slots for variables, or the slots are variables. And the LLM's job is to go out to the data being reviewed, whether that's output from another LLM, a document that's being processed, any bit of information or content that wants to be checked against a set of rules, is where the LLM goes and grabs values that gets plugged into these variables. And then that package, technically speaking, it's called hydration. The hydrated programs then get run through the solvers. And that's when we can apply formal methods. That's when we can have that traceable logic and audit trail that comes with every determination. I've already covered most of this. The left side is very much probabilistic. Symbolic reasoning is where you can get to determinism, or as close to deterministic outputs as possible. LLMs are still in the mix, but we can get to high 9s of accuracy with this approach. All right, and proving it, we did a benchmark study, a number of benchmark studies actually, where we pit ourselves with the latest models, like from OpenAI and from Google. We've since done experiments with Anthropic as well, where we have a RAG-based approach and then a Jaxon plus those same models and our approach. And all of them were what we call complete. All of them tried to enforce a rule. So if you have a set of rules and you include it in your context, and it is part of the prompt, if you will, the LLMs are going to try to enforce every rule you ask it to enforce. And that's how most people are going about rules enforcement right now. So it is going to try. They're all going to be complete. At least the latest models are. Consistency is where it starts to break down, and correctness obviously is a big issue here. But the consistency of applying a rule the same way every time is where we shine, because it's code. It's just like software. It's going to compile the same way every time. So consistency is a big benefit of the Jaxon approach. And then ultimately correctness and accuracy and trust in the outputs is where we also add a lot of value. All right, I'm going to kick it over to the demo. All right, so I'm going to start off here talking about FINRA. Oops, go away. FINRA 2210. This is a policy put out. It's a reflection of the Securities Act of 1933, which is a law, and the FINRA interpretation of that law, and then further still, the companies that have to adhere to that regulation and their interpretation of it. Here, let me try to quickly pull it up for you all. So this is a fairly long document. Here it is, where someone has gone through, again, that Securities Act and turned it into a policy, if you will, a whole bunch of natural language descriptions of what to do and what not to do. What we've found in this use case and use cases that we're doing with Department of War and in insurance and in life sciences, what we're finding is the individuals, say the analyst or the compliance team's interpretation of this natural language is quite varied. So how can we ground that in something that's more consistent? And how can we glean that institutional knowledge from the analysts, from the subject matter experts, and bring it into our more rigid approach here? So we ingest this whole thing. Let me go back over here. And that comes in as a document, and then we create rule sets against it. We have LLMs that power the extraction of the natural language and the conversion into DSAIL, that's our code, and then the claims that come with that. And the claims is where the LLM comes back into the picture to go out back to my ARM example, find the values, plug them in as variables to those slots, and then gets formally solved through they're called SMT solvers. That's what we favor anyway. All right, I'm going to dive into one of these specific rules. I like to talk about this no performance projection. And you'll see the natural language that reflects the FINRA 2210 policy, the code that comes from that, and then going down into the claims that directly correlate to that code, and the questions being asked of the data when we get to runtime to find representative answers. So this question right here is fairly broad. And so how most people have solved this problem over the years is to come up with a whole bunch of keywords and key phrases that would trip a more lexicographical approach. And that really breaks down when you have language that's quite varied. And that's how natural language really is. And that relates to why rules engines of your were so hard to implement, is because of that variability, especially in the natural language processing space. So back to my point about institutional knowledge, this is where it can be added. This is where the additional context for this specific question can be added. And that can be done by an individual. It can be done by multiple people, and there can be consensus that gets arrived at for the gold standard across the company. All right, I have this already teed up with an email. This is, here, I'll show you the actual email. An email that does not have any keywords in it, does not have any key phrases that should trip it. There's no word guarantee in here. Yet this is a promise of performance. So we bring that in and we run it up against the rules. In a runtime setting, you'd run it up against all the rules, and I'll show you that in a second. This is just up against this rule number 5, and you see that it has produced a false on it, which means it has not been satisfied. This rule has been violated. This is what I call an evaluation payload. What is done with it from here is an implementation decision. So our role with DSAIL is to flag rules have been violated, or again, satisfied, or not enough information to determine, aka unknown. Agents can sit on top of this. Software applications can sit on top of this. A web app, anything really can consume these evaluation payloads. So what we've done is created an environment where we can spin up agents really quickly that align very well to this concept of rules enforcement. Yet it is tailored toward the analyst, not the engineer. What I've been showing so far is tailored toward the engineers, the subject matter experts, to get the rule sets in order. Now we're going to leverage that rule set in a runtime setting where an analyst can come in and confirm or deny the AI's recommendations. And that's another key here, that with what we've done with Department of War, what we're seeing in financial services and insurance for these high assurance use cases, a human still is in the loop, but they don't have to go through all the grunge work, all the mundane effort to read everything. They're just reading the determination from the agent and agreeing with it or not. Little bit of a tangent here. One of my advisors is really hot on this topic, is decision degradation or decision integrity, where if the AI keeps making good recommendations, at what point does a human just agree with it all the time? And so I do want to flag that as an ongoing issue. I think that's a cultural thing. It's a training thing. But it is an interesting topic. Would love to debate it with someone at some point. Anyway, back to this here. So I ran this before, and you can see that we have an email that is being evaluated right here. And then we can get all the reports out on all of the emails that we're evaluating. We can look at one email at a time and review it, see the determinations that were made by the rules engine or DSAIL, and come in here and do the confirmations or rejections. Now, at some point, back to my topic of when do you just trust the AI, a lot of these will start to have confidence levels where the ones that are super high confidence can just fly through. The ones that really need human interpretation, which fortunately we're still good at as humans, can be flagged and put into this queue. Because you don't want to have to review every email. You just want to look at the ones that are actually really concerning. So we have the confidence level here that we've put in. Again, this is a cultural and adoption thing, and Jaxon can help with that as well, since we have a lot of experience bringing LLMs into the fold. All right, I think I have covered everything I wanted to cover, so thank you all for joining. I'm going to take a breath and look to see if we have any questions. All right, we have one about deployment. So I mentioned AWS Marketplace. Let me see if I can quickly find that link and put it into chat here. So anyone can come and start using Jaxon now. Let's see, how do I do this? Comments to everyone, join the chat. Oh, geez, there's a whole big effort here. I might have to do this after the call. You know what I'll do is I'll post this on LinkedIn on our company page, or someone on the team will add this to the company page, and y'all can get access to it that way. All right. So AWS is an option. We work on Google Cloud, Azure, and IBM Watson. IBM's been a great partner of ours, so we're available and integrated into the Watson X environment. We are deployable on-prem. So we've been, again, working, I've mentioned this a few times, working a lot with Department of War, where access to the internet for a lot of the applications is just not possible. So we have designed it to work in disconnected mode. So it can be housed in the cloud, can be on-prem, it can be in an air-gapped environment. And you call on Jaxon via API. Here's another thing that I could put in to a LinkedIn post is we have our documentation at docs.jaxon.ai, and you can read about our API, and this is where you gain access to those evaluation payloads. You get the rule set set up, get the API connected, and then you're off and running with whatever application wants to call on that. And that could be one that we help you create, like the FINRA shipyard app that I was describing earlier. Shipyard's our internal term for this application layer, or the agent creation environment. Or it could be your existing agents, your existing software applications that call on this API and get those evaluation payloads. We're a nice verification layer in between before the end users get it, saves a lot of false positives, and gives you a lot more trust and auditability in the process of engaging with and deploying LLMs in your workflows. So we'd love to talk with anyone that's interested in learning more. You can reach out to us at info@jaxon.ai. Thank you all.